Hi, so in this video we're going to be working with introduction to the quadratic function, right? We've been working already with a linear function, so the exponent is 1. Now we're going to be working with the exponent 2, right? With this x squared exponent, right? So quadratic function is a function in the form of y equals ax squared plus bx plus c, where a is not equal to 0. The graph of that function is a parabola. We're going to see it a little bit later. Yeah. There's a couple of ways of writing it. The first one that we're going to be working is the vertex form, right? The vertex form quadratic function is y equals a times x minus h plus k, where again a cannot be equal to 0, right? The axis of symmetry, once we trace the graph, we're going to see it better, is that line that divides the parabola into two mirror images. So what is happening on the left side of the axis of symmetry is also happening exactly the same way on the right. And the equation is x equals h. As you can see here, it's going to be the opposite of that function, right? Because I have minus h, so it's going to be the opposite. And the vertex of the parabola is that point where the parabola and the axis of symmetry intersect. It's going to be hk. Again, as you can see, the h is the opposite because in my equation I have minus h, right? So let's start identifying all that information so we can trace. So maximum value, a minimum, we're going to see a little bit later on the graph so you can see it better. But if the a value is positive, the parabola is going to open up, something similar to this one. And it means that it is going to have a minimum value of that function, and that y equals whatever is on the vertex, right? Right. And if the a is negative, so that graph is going to open down like this one. This value right there is going to be in the maximum value of that function. Right? So I have y equals x squared. So this is the parent function. This is the parent function. Parent function of the quadratic equation or the quadratic formula function. Sorry. Right? So my first step, I'm going to identify my vertex. So my vertex in this case is 0, 0. My axis of symmetry is x equals that x value of the vertex, right? So x equals 0, right? So now I'm just gonna start by marking that information. So I'm gonna start by marking 0, 0. There's two ways of just doing it, right? I'm gonna trace my axis of symmetry, as you see, and I'm tracing in dotted line because it is it's not part of the function, right? So now I can substitute point. So let's add really quickly here a table. So really quickly here a table x f of x. So that means that I'm substituting that f and y, and then I have the point x, y, right? So I'm going to start by choosing 2 points to the right, 2 or 3 points to the right of that axis of symmetry. So I'm going to substitute x equals 1. So x equals 1. So I have 1 squared equals 1. So I have the point 1, 1. So I'm going to mark that point right here. I'm going to do the same with 2. 2 squared equals 4. So 2, 4. 2, 4 is this point up here, right? And now, because it's the axis of symmetry, remember this axis of symmetry is a line that mirrors everything. So what is happening to the right is also happening to the left. So if I mark that point 1 unit to the right of the axis of symmetry, I'm going to mark that same point 1 unit to the left, and the same over here, right? And now we're just going to trace the line right there, right? The parabola is like an U, right? This is important because this is a parent function and we're going to be comparing what's happening with my function. I'm going to even use this later on to show you how to graph. The next one, I have x plus 2 squared plus 2. First of all, I'm going to identify my vertex. Vertex, right? Again, the vertex is the opposite, negative 2 and 2. right? So for x is the opposite that is on the equation. For y is exactly the same, right? My axis of symmetry is x equals -2. Again, it's the same value of the x on the vertex. Right? Now I'm just going to mark those points. So -2, 2 is this point right here. I'm going to draw my axis of symmetry around here, right? And I'm going to choose points. So my table again, x, f of x, y, x, y, right? So again, I'm going to choose 2 points to the right or 2 points to the left. That's your decision. So I'm going to substitute -1, -1. So I have -1 plus 2 square plus 2. So -1 plus 2 equals 1 square. 1 square equals 1. And 1 plus 2 is 3. So I have the point 1, 2. Right? I'm going to substitute also 0 because it's the next point. So -1 is 0. So I'm going to substitute 0. So 0 plus 2 square plus 2. I have 2 square. 4 plus 2. This is 6. 0, 6. And I'm going to mark those points. So -1, 2, -1. Sorry, -1, 3. This should be a 3 right here. -1, 3. -1, 3 is this point right there. -1, 3. And the point 0.06 is this point right here. And again, from my axis of symmetry, I'm going to mark on this case. As you can see, I have the 0.5 line. So that means that I'm going 1 and 2 to the right. So now I'm going to move 1 and 2 to the left. So I have this point right here and the same up here. Right? And there I'm going to draw my graph. Right? And I'm going to use this graph to go over something, right? This point right here, my vertex, as you can see, is the lowest point, the lower point that I have of the graph. There's nothing on the graph. There's nothing on the graph below that one. There's nothing down there, right? So that means that everything else, every single value of y is up there. So that means that this graph has a minimum value, value at y equals 2. At y equals 2, right? My value of the smallest value of y is going to be on that point. Everything else is going to be bigger, right? So I know it by looking at a. My a value here is positive, so that means that my graph is going to open up. It's going to open upward, so that means that my vertex is going to be the minimum value. Okay, so x plus 2 squared plus 1. First, I'm going to start by identifying my vertex. So my vertex is -2, 1. My axis of symmetry is x equals -2. So x equals -2. -2, 1 is this point right here. This is my axis of symmetry. Okay, so I'm going to start by, again, substituting -1. So I'm going to substitute -1. So -1 plus 2 squared plus 1. So 1 squared plus 1 is 2. So I have the point -1, 2. Now I'm going to substitute 0. So 0 plus 2 squared plus 1. So 2 squared plus 1, 4 plus 1 is 5. So 0, 5. Now 0, -1, 2, and 0, 5. And again, I mark 2 points, 2 units to the left, or 2 spaces to the left. So I'm going to mark it to the right, sorry. I'm going to mark it 2 spaces to the left. So 1 and 2. And here the same. I have 1, 2, 3, and 4. 1, 2, 3, and 4. And I'm just going to trace my graph. Okay, so again, this one, my vertex is 4, positive 3. Again, remember that it's the opposite of the equation, so that's why it's 4. So 4, 3 is this point right here. Axis of symmetry. Axis of symmetry is x equals 4. So it's this line that goes right here. Right, and I'm going to substitute it. 5. So I have f of 5. Right? Remember that f of x is another way of writing y. It's the same as y. So f of 5 means that I'm going to substitute on the equation 5. So 5 minus 4 squared plus 3. So 1 squared plus 3, 1 plus 3 equals 4. So from this information, I have the point 5, 4. Then I'm going to substitute 6. So f of 6 equals 6 minus 4 squared plus 3. 2 squared plus 3 equals 4 plus 3 is 7. So I have the point 6, 7. And I'm going to mark those points. So 5, 4. 5, 4 is this one right here. 6, 7 is this one up here. And again, I'm going to count. So I have 1, 2 to the right, 1 and 2 to the left. I have 4 to the right, I have 4 to the left. And I'm just going to trace my graph. Right? And again, this one has a minimum value at y equals 3. The next one, this one changes a little bit because I have that 2 in front of it, right? Let's see what's going to happen with the graph, right? So my first thing is that the vertex is going to be exactly the same. So I have negative 3, negative 4. Right? My axis of symmetry, again, is exactly the same. The axis of symmetry is x equals negative 3. By looking at the equation, because this value is positive value, I know that it's going to have a minimum at y equals negative 4. We're going to see once we trace the graph. So negative 3, negative 4 is this point right here. My axis of symmetry is this one. All right, so I'm going to find f of negative 2. Equals 2 times negative 2 plus 3 squared minus 4. The order of operation here is very important. So first of all, I'm going to subtract inside, so 1 squared. Then I'm going to square, so 1 squared equals 1 minus 4. Then I'm going to multiply. 2 times 1 is 2 minus 4, so negative 2. So I have the point negative 2, negative 2. So negative 2 is this point right here. Now I'm going to substitute 1, so f of negative 1 equals 2 times negative 1 plus 3 squared minus 4. So 2 times 2 squared minus 4 equals 2 times 4 minus 4, right? And this 4 right here is this squares 2 squared, right? Equals 8 minus 4 equals 4. So that means that I have the point negative 1, 4. So negative 1, 4 is this point up here. Right? So again, mark those points on the other side of the axis of symmetry. And now I'm just going to try to trace a line as. What is important is that it looks like a U down here. So as you can see, this graph, this is the smallest value that it's going to have. Everything else is going to be on top of that value. The next one. Again, my vertex is exactly the same. So I have my vertexes. Let's mark it here. Vertex, negative 3, 3. So I'm going to start by marking that. Negative 3, 3 is this point right here. My axis of symmetry is x equals negative 3. Right? And I'm not going to go over the value, the maximum minimum value yet. I'm going to trace the graph so you can see it better. So f of -2 equals -2 plus 3 squared plus 3. Remember that we're multiplying this negative sign times everything that is coming outside from here. So -1 squared plus 3. So -1 squared is 1, or 1 squared, sorry. So 1 squared is 1, but I'm multiplying times negative. So that's why it's -1 plus 3 equals 2. So I have the point -2, 2. So -2, 2 is this point right here. I'm going to go ahead and mark it over here also. Okay, I'm going to substitute, let's say -1. So f of -1 equals negative times -1 plus 3 squared plus 3. So negative times 2 squared plus 3. Again, I have this negative outside. I know that 2 squared is positive 4, but because I'm multiplying times negatives, it's going to be -4 or -4 plus 3. This equals to -1. So here I have the point -1, -1. So -1 is this point down here. So and now I have my graph. Right, as you can see, just by looking at the values of the graph, that graph is opening down. What is the difference between the other ones? That this number is negative. So if my a value is less than 0, so it's a negative value, my graph is going to open downward, so it's going to open down like this one right here. And now in this value, instead of being a minimum, now it's going to be a maximum value at y equals 3, right? Again, y maximum, because as you can see, up higher than this value right here, I don't have anything on the graph. Everything is below that graph, so that means that this is my maximum value of that graph. And that's it for the lesson. May the force be with you.